just continue solving our midterm exam problems. So ako lang siyang idugang diri sa tuang gigamit po nga PowerPoint para sumpay lang bitaw siya para isa lang ako ang ihatag sa inyo ang file for the solution of midterm exam nga problems. So, okay ra kung audio class? Madungog ba ko? Okay, so I hope nga dili ra kayo mo ma-distract sa background noise, no? Since there are also other instructors who are conducting their online classes po. Anyway, sige. Wait lang ha, i-open sana ko yung exam questionnaire. So, di ba as kita last time nag-stop? Situation 3. Sige, continue ta with situation number 4. Situation number 4. Wait, ako sa copy ang figure. Okay. So we have here the 1 meter diameter chandelier shown below is supported by 4 steel cables. No? So gihatag ang modulus elasticity of the material nga steel which is 200 gigapascal, and it says na the diameter of the steel cables kay 4 millimeters each. Sige. So if the cable has an elongation of 0.20 millimeters, determine the weight of the chandelier. So assuming equal distribution of forces among the 4 cables. Okay, so ang condition na gihatag sa ato class is elongation, no? Which is 0.20 millimeters. So we are to determine the allowable weight of the chandelier. No? Okay, so allowable weight ang ato ang i-compute of the chandelier. So the chandelier is circular, no? Ang iyang top view since it has a 1 meter diameter man daw. So dako, chandelier class, no? Kay 1 meter man diameter. Sige. So how do we solve for this? So total allowable weight, no? So take note ha that your weight of your material should be acting, or the line of action of the resultant of the weight of your material, it should be acting at the centroid of the material. That is why the line of action of your force weight is reflected, no, in this manner. Sige. So deformation, no, ang gihatag nga condition, then gihatag pod ang modulus of elasticity. So di ba we have the equation of deformation as deformation is equal to P over PL over AE, no, or play ang monatic kanato ani, no. Play. So PL over AE. So we are to determine for the original length, no, of our cables. So wala gihatag sa problem class ang iyahang length. Since kaning 800 millimeters, this is the vertical distance, no, of the support until the chandelier. Then ang internal reactions of each cables. So, unknown. Wala gyapon ta kabalo. So, gihatag na ang modulus of elasticity. So, we have data for this. And then, ang area of each of the cables can be computed since gihatag man ang diameter of each cable. So, wala problem na with AE na input. And also, si deformation, di ba gihatag man siya na elongation of 0.20 millimeters lang dapat. So, we have data for this also, no? So, P and L ang ato ang concern. So, to solve for the total weight no, of the allowable total weight of the chandelier, so it has something to do with the strength no, or the internal reaction of your cables. That's why our goal in this problem is to compute for P. And then eventually, makuha na nato si W. Okay, so sige. So to compute for P, so if using this equation, we have to find L first. Para using this equation, siya na lang ang unknown variable. Okay? So how do we find for the original length of your cables? So notice na if ato na siyang illustrate no 3D niya. So centroid of your circle is acting here or at this point. So if we are to analyze one cable as a representation no, of four cables, so makakreate actually ano triangle, 'di ba? So using that triangle, so sa kuan class no mechanics or sa engineering mechanics nga subject class, it's all about finding relationship for the geometric relationship na of your structure para ma-compute nimo ang mga pwede ma-obtain nga values or pwede ma-obtain nga data such as this one. So, di ba, ang ato ang goal is to compute for the length of your cable. So, ako lang siyang i-label as LC. So, by this triangle, di ba, we have a right triangle. And the height of this triangle is given by this 800 millimeters. So, if this is 800 millimeters, how much is the base no, of our triangle? So, di ba, um, it is just the radius of your chandelier. So, given man ang diameter. So, meaning, which is 1 meter, meaning, ang imuhang um, base no, sa imong triangle is 0.5 meters. So, to compute for the total length or the original length of your cable, you have LC. So, apply Pythagorean theorem lang. Kay right triangle naman na siya. So, square root of 0.5 squared plus 0.80 squared, no? Or 0.8 squared. So, ako lang siyang i-convert into meters para compatible ato ang units. So, the resulting unit for your length no, of the cable is in meters. So, square root of 0.5 squared plus 0.8 squared. LC is 0.943 meters. So, na-obtain na nato ang length no, of your cable. So, applying that one here sa atong equation or sa atong formula for deformation, you have deformation nga 0.20 millimeters. So, 0.20 millimeters. So, ako na lang siyang i-convert into meters. And that is, ang conversion factor is 1 over 1,000. Equal now to P, which is unknown. Then, length na of your cable nga 0.943 all over the area of the cable, which is ano lang pi over 4, d diameter na to is 4 millimeters, di ba, each? Therefore, in terms of meters, you have 0.0004 class, no, as our diameter, 0.004 times the modulus of elasticity of steel nga 200 gigapascal. So by this, excuse me. So by this, no, in this equation, isa na lang ato ang unknown variable. Makompute na nato siya ang P. So therefore, P is, how much is P? 0.20 times 1 over 1,000 is equal to 0.943 times P nga unknown all over pi over 4 times 004 squared times 200 times 10 to the power of 9. So P therefore is equal now to 533.038 newtons, no? So the resulting unit for P is newtons. Since diba, this is in meters, then may mo na siya meter squared, no, ang iyang unit. And then this one is gigapascal. So Pascal is Newton per meter squared. Okay? So for a while ha, nakoy nadunggan na, okay. So thank you no kay nag-calculate po dahil mo. Dili ang kaayo na ko ma-acknowledge no inyong gichat. Kay all I can see is, sa akong screen is, kanilang PowerPoint. Anyway, sige. So now, since na naman tayo value for the internal reaction, no, of our cables, how do we compute for W? So since, di ba we'll have this illustration. If atong ikat, no, ma-show ang ilahang internal reactions na of your cables. So, muna sila si P. So, let's say na adre ang centroid ha. Then, so this is the weight no of your chandelier. This is P. So, if ato bitong i-consider ang 1P lang, kanilang siya bitaw class. So, we'll have this illustration, di ba? So, if this is P, then W. So, we have this illustration, no? Or free body diagram. Then, your P, no, has some angle of inclination. So, we can actually solve for W by using the equation of equilibrium, no? So, summation of forces on y-axis equal to 0. So, W, which is negative sign convention because it's downward, then plus the y component of P, no? So, P sine theta. But since, di ba, you have 4P man, so, i-multiply na to siya by 4. Kaya upat man kabuok ang mo resist no sa iyang weight sa imong W. So we have this equation and since na-compute man ang P, okay, wala pa tayo theta no angle theta para ma-solve din nato ang W. And how do we determine angle theta? So nara na siya dari nga triangle proof class no. So makuha po nato ang iyang angle of inclination by tangent function. So tangent of angle theta is equal to 800 over 500. So angle theta therefore is 57.995. Tama. Sige. So eventually, ma-compute na nato si W, no? So, transfer lang nato si W na sa left side, but ako lang siyang i-rearrange no, in this manner. So, 4 times P nga, 533.038 sine 57. Okay, ako na lang siya i-as is no, as angle theta. But, take note ha nga, i-substitute nato of course ang value sa ato angle theta in order for us to solve for. So therefore, W is how much? Ang allowable weight no, of the chandelier. You have 1,808.069 newtons. So this is now our final answer for situation number 5. Situation number 4 rather, no? So I think, di ba, naka-example man taan ni sa to ang discussion pod on this topic. So same, ano lang, di ba, material, no? Mga chandelier. So, I hope nakuha no ang concept. So, questions or clarification so far? Sige, padayon ta with our discussion. So, situation 5. Okay. So, situation 5. A rigid bar with negligible mass now is pinned at O and supported by two vertical rods. So if the allowable stress in steel is 150 megapascal and in aluminum is 70 megapascal, you are to determine for the value of P in terms of kilonewton without exceeding the allowable stress in steel only. So regardless of the um, internal reaction of bronze. For part B, the value of P in terms of kilonewton also without exceeding the allowable of stress in aluminum. Aluminum, no? So without considering the allowable stress no, in steel. So baylo po sila no, si part A at si part B. Sige. So this is actually a case of statically indeterminate nga structure class, no? Kay if we are to determine the internal reactions na of these two materials, dili na to siya ma-solve using only the equations of equilibrium. Okay, we have three unknown variables man ani, no? And then, let's say, nag-apply ta no og force P at this point. So, ang rotation no, sa imuhang rigid bar would be in this manner. Diba? So, if we are to disregard the connection no, at these points, so if these are kaning free rotation nga points, no? So, ang imuhang bar, inana yun no, ang iyahang may tabo nga rotation. Kay, imagine na lang no, ang swing. So, if magbutang ka og load no, at this part, so, di ba, inani magid ang itsura sa imuhang swing dayon. So, meaning class, no, your reactions at steel and your reaction at aluminum would be iyan ang i-resist nga force, no? So, inani ang mahitabo. So inani ang itsura no sa reaction ni kang steel and aluminum to resist force P. Kay para mabalance na niya ang swing no or para mabalance out niya ang force P. So mo na ilahang role no ilahang purpose ni steel and ni aluminum to balance out force P. Since we are aiming for the static equilibrium nga status or nga state sa ato ang structure. Okay? So, ako lang i-delete ha. So, if it ato i-drawing mo ang iyang free body diagram with those exposed ang iyang internal reactions, so we will have this illustration, di ba? So, if this is P, then si point O, and then C, steel, and C, aluminum, no? So, di ba ilang internal reactions, kay inani ang orientation. So, ako lang ni silang i-label as si PS, no, for steel, no, internal reaction of steel, and then the force, no, internal force at aluminum, sorry, PA din siya. Di ba? So, if si point O lang, no, ang ato ang support, and let's say nga, free rotation ang ato ang points PS and PA. So, dapat class, no, ang iyahang figure na, no, is, or sa iyahang deformation. Wait ha. Hindi siya makopy as a whole. So, if this is the rigid bar, and then si point O, so if nag-apply tag force P here, so your rigid bar will rotate na in this manner. So, nara si point O. Diba? So, si PS, no? Diba, diri man originally ang point ni PS and also point of support ni PA. So, mainat kibali sila class, no? So, there will be deformation. Ma-deform ang ihang structure or in this case, ma-elongate no ang material. So, it will have this elongation or deformation. And ato lang siyang i-label as deformation of steel and deformation of aluminum. Diba? Sige, so let us establish the distances no, or the length. Sorry, this is 1.5 lang di ay. And also 1.5. Sige. So, di ba nga to ang approach no or ato ang analysis on the structure statically indeterminate na structures, we are to relate the geometric deformation of our structure no para makakuha taog equations of compatibility. So ato ni siyang i-relate no ang iyahang deformations no for both materials. So by ratio and proportion, you have a deformation of steel over 1.5. So small triangle is to big triangle, no? So height no sa imong big triangle would be si deformation of aluminum. Then base no sa imong big triangle would be 1.5 plus 1.5 which is 3 meters, no? Sige. So meaning class, mas kuan siya no, mas easier if si 3 ang ako ang i-cross multiply para may mo na siyang 3 over 1.5. So that would be 2, no? Therefore, class no, ang ratio or ang relationship ni deformation of aluminum to steel is just equal to 2. Diba? So if imo na siyang i-cross multiply, so you have 3 over 1.5, that would be 2. Okay? So, naanataan ng relationship. But, since force P, di ba, or ang value of P man ang ato ang gina-obtain, so let us express, no, or let us create an equation for P. So, how do we solve for P? So, by this illustration or free body diagram niya, let us take moment at point O, no? para ma-compute na to si P. Sige. So, summation of force, summation of moment at point O equal to 0, having counterclockwise as positive. So, you will have, ilagay niyo siya, this is 2, 1.5, and also 1.5. So, this is hinge siya. So, summation of moment at point O equal to 0. So, force P or CP will create counterclockwise rotation, no? Meaning positive sign convention times 2, iyahang moment arm, no? Minus PS. Since PS will create clockwise rotation with respect to point O, that's why negative ato ang sign convention for PS times moment arm nga 1.5, as well as si PA, no? Negative sign convention times moment arm nga 1.5 plus 1.5 is 3 meters, no? So, equal na to 0. So, meaning class, no? Your P is just equal to, i-transfer na to siya, that would be 1.5 PS plus 3 PA over 2, no? So, this is now our equation number 1 actually. So to compute for P class, no? So we are to find PS and PA. And where do we find that? So using this equation of compatibility, so i-relate na to ang deformation o ang iyahang internal reaction. So first, atong pangitaon si deformation of A para makita na to si PA, no? Kaya di ba equation for deformation is just equal to play. So PA times LA over the cross-sectional area of aluminum times the modulus of elasticity for aluminum. So, substituting the data given, PA is unknown. So, LA, the original length of your aluminum, which is 2 meters, di ba? So, times 2 over the cross-sectional area of aluminum, pila to? 300 millimeters squared. Sige, so since this is in meters, so we are to convert, no, for 300 millimeters into meters. So conversion factor is just 1 over 1,000 squared, no, times the modulus of elasticity of aluminum nga 70 gigapascal. So 70 times 10 to the power of 9. Therefore, class, no, the deformation of your aluminum is just equal to 2 over 300 times 1 over 1,000 squared times 70 times 10 to the power of 9. So you have 9.5238, no? Times 10 to the power of negative 8 PA. Okay? So, tama ba? Sakto ba tayo? Parehas pa taon na nga compute sa inyong end?
Yes, sir. Paliara, sir.
Okay, sige. Sige, so for steel, the deformation of steel equal now to the modulus of elasticity for steel. Length of your steel or original length of steel is 1.5 meters, di ba? 1.5 meters over the cross-sectional area of steel nga 900 millimeters squared. Excuse me lang class ha, na ay concern. So, for a while lang. Okay, so sorry for the interruption class no kay na ay concern na gi-raise ang isa ka parent. Anyway, so continue lang tanong asa na itang part. Okay, so for steel na tanong. So the deformation of steel, di ba, you have PL over AE and
Diri daw kung sir ang bits office ang form.
unsa na
Ang grade to certificate of completion bitaw.
change of grade,
Ha?
change of grade.
Oo.
So sa iya na instructor unsa na nga subject?
Sa calculus niya sa
O ina iya instructor nga ang instructor magud ang mo process sa change of grade.
mismo one din.
Oo, dili. I-submit ra na ng instructor sa dean's office ang form. Oo. So if
Okay, wala man ang ingon sa yung
unsa ingon sa instructor?
Dili ko siya ka-access sa presence, dili siya ka-edit mo na.
Dili i-inform ina siya na kanang i-inform niya ang instructor nga dili na siya na i-fill upan nga forms instructor and then i-submit niya sa dean's office for change of grade. Dili si instructor mismo ang access sa pre-sem. Si registrar na ang mo change ana kay change of grade man na siya. So dili na siya niya ma-access iyang pre-sem o form na i-form para ana ina siya nga ipangutan ng instructor ug asa siya makakuha adtong form kay lahi yes oo sige sure okay anyway bala nakadungog mo sa chismis for the cross-sectional area no, of steel no, for air computing for steel sige so 900 millimeter square you have 1 over 1,000 no, as our conversion factor times the asa na ta modulus of elasticity of steel. So 200 gigapascal. Sige, so now the deformation of steel no as a function of the internal reaction of steel it would be 1.5 over 900 times 1 over 1,000 squared times 200 times 10 to the power of 9. Okay, so we have the same lang, no? 8.333 times 10 to the power of negative 9 Pascal. Sorry. This is not Pascal, no? Kay kuan man ni siya class. Sorry, sakto to PA man ni, no? I thought Pascal, nalipog ko sa iya sa akong gisulat. So this is PA, no? Internal reaction of aluminum. Nakurat ko nga naman ang deformation mo, no? Pascal akong unit diri. This is PA man dahil, no? So this is deformation of steel is equal na to 8.333 times 10 to the power of negative 9 as a function of the internal reaction of steel, no? Or CPS. Diba? Sige. So, if we have this PS and PA class, no? Internal reaction nila, then ato lang i-substitute no ang ato ang deformation of the aluminum and your deformation for steel para makita nato ang relationship na pod sa internal reactions now of your materials no nga si steel and si aluminum kay nakakuan man siya no naka-express as deformation and we are actually computing for P no so PS and PB ang PA ang ato ang objective here. So to do that, we have this deformation of A is equal to 2 times the deformation of S. So deformation of aluminum is diba 9.5238 times 10 to the power of negative 8 PA equal now to 2 times deformation of steel na 8.333 times 10 to the power of negative 9 PS. Sige. So if we are to express si PA, no? So divide both side by 9.5238 times 10 to the power of negative 8. So 2 times 8.333 times 10 to the power of negative 9 over 9.5238 times 10 to the power of negative 8. You have 0.17 PS. Diba? So, morning relationships atong internal reactions no, of both materials. So, sige. So, basing on that, no, let us answer part A. Diba, ang condition lang for part A is the value of P no, in terms of kilonewton without exceeding the allowable stress in steel. Sige, so if the allowable stress at steel is equal to pila to siya? 150, no? 150 megapascal. We are to compute for the value of P. Sige, so pila pod ang value sa ato ang maximum allowable internal reaction of steel. No? So for PS, if ang iyahang allowable stress is 150 megapascal. So PS over A, no, kay equation for our normal stress is just um, normal stress is equal to P over A. So cross-sectional area of steel, or PS over the cross-sectional area of steel. How much is our area for steel is 900 millimeter square, diba? So therefore, PS class is pila man ni siya. You have 135,000. And then, so if the allowable, no, allowable internal reaction of steel is 135,000 Newton, how much would be PA? So we can compute that by using this relationship, know that the PA is equal to 0.175 of your PS. PS nga 135,000. So PA is 23,625 Newton. So, di ba we have now values for PS and PA, no? With accordance to the allowable stress at steel, 150 megapascal. So, makompute na nato ang value for P. Kaya we have this equation man, no, for P. No, nga 1.5 PS plus 3 times PA all over 2. So, makuha na to ang P. So 1.5 times PS plus 3 times PA, diba to? All over 2. So substituting the values, you have 1.5 times PS is 135,000 plus 3 times PA nga 23,625 all over 2. So, P is, pila man na siya class? $136,687.5 newtons, no? So take note that the problem required us not to express it no in terms of kilonewton. Therefore, this is just 136.688 kN. So this is our answer for part A. Sige, so for part B, so the other way around, no? How about if kung i-consider lang is ang allowable stress no in aluminum. Pila to? Ang allowable stress for aluminum, di ba? 70 megapascal. So, by the equation or formula for the allowable stress nga P over A, so 70 times 10 to the power of 6 is equal to PA, internal reaction of A, over the cross-sectional area of aluminum, nga 300 millimeters squared. So we are to convert it to meters squared. So makuha na to ang allowable internal reaction of aluminum, no? And how much is this? So times 300 times the conversion factor squared, you have 21,000. Diba? So how much is PS if you have an internal reaction of 21,000 Newton no, for aluminum, no? So, di ba itong equation or relationship ni PA and PS is PA is equal to 0.175 of PS. So, by that, PA equal to 1.175 of PS. Makompute na to ang S, no? By dividing both side by 0.175. Therefore, PS is how much? 120,000 Newton. Sige, so ma-compute na gyapon na to ang value of P. Kay we have an equation man for the value of P or on obtaining the value of P. Diba? This is our equation number 1. 1.5 times PS plus 3 times PA. Tama ba? 1.5 PS plus 3 PA over 2. So, substituting the values for PS and PA, plus 3 times 21,000 all over 2. Therefore, the value of your P, no, is equal to 121,500. So again, take note na in terms of kilonewton no ang i-require sa problem. So P therefore is 121.5 kilonewton. Okay, so these are our answers for situation number 5 class. So actually class no, napa ni siya sumpay. Letter C. Find the value of P in terms of kilonewton without exceeding both the allowable stress no in both materials nga si steel and si aluminum. But excuse me. Our solution to that is it would just be the same sa ato ang solution sa part B. Kay nga naman, so to solve for that, no, if na atong letter C nga problem or nga question, ang ato lang buhaton is we are to determine the values of PA and PS also, di ba? And to do that, naingon di ba si internal reaction of aluminum nga iyahara yung makaya nga internal reaction is 21,000 Newton if dili ta mo exceed sa iyahang allowable stress nga si 70 megapascal. So, mamili ta og value for PA. So, since your PA, no, by, if i-base na to siya sa stress sa steel, you have 23,625 newtons, and the maximum allowable internal reaction is only 21,000. So, na-exceed siya, no, if atong i-consider is ang sa steel. That's why ang piliyon nato nga value or ato ang i-adapt, no, nga value para dili mo exceed in both steel and in aluminum nga material. Ang internal reaction ni aluminum would be 21,000 newton. Okay? And then for PS, for aluminum na basis, you have 120,000 newton internal reaction of steel. And in allowable shear, not shear, allowable normal stress, no, of steel is only internal reaction niya is 135,000 newton. So, unsa nga value ato ang i-adapt? So, of course, you are to adapt the value of internal stress of steel nga 120, sorry, yeah, 120,000 newton. No? Kay mas less man siya kang 135,000 newton. Okay? Kay meaning, pag good class, if ang imuhang gamito, no, nga value or ang imuhang i-adapt nga value for internal reaction of steel is 135,000 newton, so dili kaya kung sa imuhang aluminum nga material. Kay niingon man siya nga if 135,000 newton ang imuhang internal reaction of steel, your internal reaction for aluminum is 23,625 man. And says here nga ang allowable internal reaction nga makaya lang gyud sa imong aluminum nga material no is 21,000. So dili siya kayahon sa imong aluminum if ang internal reaction of steel is 135 newton. That's why ang atong i-adapt nga value for steel or internal reaction value of steel is 120,000 newton. Kay para both in aluminum and in steel, dili mo exceed ang iyahang normal stress for both materials. Okay? Sige. So, let us proceed with the last problem, no, sa to ang midterm exam. So, situation number 6. And this topic is actually the latest, no, nga topic na to nga na-discuss. So, mali ato ang topic nga di-discuss before ta nag-midterm exam. So, fresh pa gid unta to sa inyong memory, no, ang atong discussion. So, this is about debate portion. Okay, so we have now here the figure rings, no, at the ends, and then ang three given torques, no. So if the diameter of the shaft is 50 millimeters, so muna siya si shaft class, no. Yadang diameter is 50 millimeters. So the bearings, no, at both ends allow free rotation of the shaft. So walay resistance na ang ato ang bearings at both ends. So determine the maximum shear stress developed in the shaft. So we are to determine the maximum shear stress developed in the shaft. So provide torque diagram. So okay, we will be solving this one using a torque diagram. So if ato na siyang i-draw iyang free body diagram, no? So let us label this as A, B, and C. So if we are considering left side, no, sa ang figure, your at A, no, the return the rotation would be in this manner, and it is 45 kilonewton meters, no? And then at part na doon, point B, no? Capital point B. At that point, ang rotation would be in this manner, and it is 30 kilonewton meters. So, same lang of direction, di ba, si B and si C? So, it will have this rotation as well. So, how do we determine the sign convention, no, for this problem? Di ba, we have the right thumb rule. So, by applying that one, let's say, ato siyang analyze no using right thumb rule. So, in this manner class, no, di ba, ang direction sa ato ang torque at A is opposite, no, the direction of the curl, no, of your hand. So, meaning, negative ato ang sign convention for um, rotation at point A. And then at point B, since if ato ning i-transfer ang right thumb sa left side face of point B, so musabay, di ba? So, ana ang direction sa ato ang rotation, and your and the curl, no, of your right hand is also facing that way, di ba? Paana po siya. So, nisabay siya sa direction, meaning positive sign convention, di ba? Ang ato ang consideration. So, positive sign convention. And then also for point C nga 15 kilonewton meters nga torque, positive sign convention also, di ba? Sige. So let us draw the torque diagram. You have here negative 45 kilonewton meters, so meaning downward, no, ang iyahang direction. So, from A to B, so linear lang, no? Kaya wala na may nag-act nga external torque or torsion at member A to B. So, meaning this point is also negative 45 kilonewton meters. So, at point B, which is at this point, you have positive sign convention, di ba? Meaning, class, no, musaka tanong from negative 5, if this is 0, musaka taog 30. So, plus 30. That is why negative 45 plus 30 is negative 15. Diba? So, dali lang yapon siya nga point class. So, from B to C, linear lang dayon ang ato ang motion, ato ang direction, no? Kaya wala may external torsion nga nag-exist at that points. So, meaning this is also negative 15 kilonewton meters class. And then, eventually, the torsion or the torque, no, acting externally at point C, you have positive 15 kilonewton meters. So, meaning from negative 15 class, no, musaka taog 15 kilonewton. So, mabalik lang siya sa original coordinate nato, no? So, 0. So, na-close ang ato ang torque diagram. Sige. Di ba, ang problem or ang question is, ang ato ang goal is to determine the maximum shear developed in the shaft rather. So, ang sa kalit atong equation for the shear stress, no, in a solid shaft, di ba, you have tau is equal to TR over J, di ba? So, radius, then polar moment of inertia, no, of your cross-sectional nga figure or nga geometric shape. So for the radius, no problem since given man ang diameter sa shaft, then the polar moment of inertia is can be solved using also the data nga diameter. So T lang ang ato ang concern, no, to solve for the maximum shear stress, no, that is being developed in the shaft. So to do that, we are to consider also the maximum torsional internal nga reaction class, no, kaning si T. And asa man na nato siya malocate. So that can be located on member AB, no, or from points A to B. di ba? So 45 kilonewton meters man ang iha internal nga torsion diri no nga member class. So mo na siya nga atong i-consider no to solve for the maximum shear stress no that is being developed in the shaft. So T for the torsion it would be 45 kilonewton meters, and then wait, ato lang siyang inaog no. Oops. Like, ato siyang i-move gamay para di ra kaayo siya mo sapaw. So, the maximum shear stress that is being developed in the system or in the shaft, it would be 45 kilonewton meters times the radius, no nga si 50 millimeters. So, since naka-millimeters man na siya, no, i-convert na to siya into meters. So, radius lang man pod ang gipangita and diameter ang gihatag. So, ato lang siyang i-divide by 2 and that would be 0.025 all over the polar moment of inertia no, of circle since circular man ang ato ang shaft. No? So, kung sa itong equation, no? So, for the polar moment of inertia, polar moment inertia of a circle, di ba, it's just pi over 2 r squared. Sorry, r4 raised to 4. So, substituting the value, radius na to is 0.025 raised to 4. You have maximum shear stress no develop in the shaft equal to 1833.464.944. Okay, Pascal. Or if ato na siyang i-express no in terms of megapascal, so may hula na siyang pilaman 1, 2, 3, 4, 5, 6. 1.8335 MPa. No, but since wala man nag-indicate ang problem no kung what unit i-express ang imong final answer, so technically this is also correct. So, sorry class no, this should be ang 45. Wait, so this should be multiplied by 1,000 times 10 to the power of 3 kay, di ba, 45 kilonewton meter man ni siya. So, para mag-newton meter, so para mo-compatible ng ato ang units, it should be in newton meters. So, 0.025. So, pila na siya. So, this is Pascal na dayon kay Newton man ni siya, no? Newton per meter squared. So, if in megapascal, so ma-outro ni siya, no? So, 1, 2, 3, 4, 5, 6. So, 1,833.464 megapascal, no? So, either way, both are correct. Okay, so if you are to investigate class, if imong isolve ang shear stress, no, that is being developed at this section, no, or at this region of your structure, or in this case solid shaft, ang imong gamiton would be say 15, no, kay kani siya at this point, at any given point at this member, 15 kilonewton meters man ang iyang internal reaction. That is why if ma-compute na ta dinhi, mas less gid ato ang makuha, no. So, gipangutan naman is maximum man nga shear stress to na develop sa whole system. So, it occurs, no, at this member, no, or at this region of your structure. So, mas diri siya na stress class. Mas dako ang shearing stress, no, at this region or at this part of your solid shaft. So, questions or clarifications? Wala pangutan na class, nasabtan? Na po mo class?
Yes, sir. Need lang ipasingkin ang info, sir.
Okay, okay. Sige lang, no. Let us kanang accommodate time nun to sink in the information. Anyway, before mo i-dispose, let's have your attendance. So if you have questions or clarifications later, no, if nasabtan na ninyo or nisink in na ang information, don't hesitate to message me, no, on Facebook or on Messenger para clear na to, no, ang inyong mga queries or concerns.
Okay, sir. Thank you, sir.